All right, good morning, everybody.
Morning.
So what we're going to learn today is we're going to learn another extension of this idea of C++ classes. So what we have built so far on C++ is we have Bjarne Strauss come around and say, I don't like the procedural program forces me to do things in a specific way. I want to develop a programming language that allows me to be able to describe how objects interact with each other. So then we built off of what we learned in C with this idea of structs, and we've learned classes now. So we've learned private and public members and methods because we want to be able to do things like abstract complexity from the user and be able to hide data unless we really want the user to be able to access it or change it. And we described this idea of get and set methods to do so. We also described overloaded operators. So we're able to read in or print out to an input or output stream. We learned about addition and subtraction and multiplication operators. We've learned about comparison operators, greater than, less than, equal to. We also learned about this idea of friend operators and how that we are able to use that to be able to bring in both the input stream or output stream, as well as a instance of the class that is const and called by reference. So now we want to be able to take this idea of being able to, simulate objects to the next level. Because everybody in here is not defined by one thing. You are not just an engineering student. You are not just a Notre Dame student. There's all kinds of different categories I can break all of you down into. Some of you are ROTC, some of you live in specific dorms, some of you are not from the United States. We want to be able to break things down and to be able to define somebody or something in many different ways. However, there are things that we all have in common. Everybody in here is in some way, shape, or form a member of the Notre Dame community. We have Notre Dame faculty, that's a difference. So I'm an employee and you're a student, but we're all still a member of the community. So we all should be able to have the similar things. We all have ID cards. We're all able to park on campus or be able to get into certain places. We want to be able to define both our similarities and our differences. And so a person can be many things. So here, I've just defined freshman, sophomore, junior, and senior. The overwhelming majority of you are sophomores, but there are some juniors and seniors in this class. So I want to be able to define everybody in those specific ways. So here's how we might do this. So as a Notre Dame student, everybody has an ID number. Everybody has a certain number of credits that they've taken. And then you have some sort of way in which you can register for classes. And inside, we can have private methods like prerequisites. We can check a course ID and then based on some information you have, determine whether or not you've met the prerequisites to be able to register for that class. Likewise, we can have some sort of method to check to see if we have enough seats that are available in that class. And likewise, we can add in and see if you've reached a particular number of credits. However, if we want to break this down, if you remember, I gave this same animation earlier in the semester, but there's certain tasks that certain people in different classes are doing. So for example, the freshmen have to account for this first year of studies program. So we can write some sort of class method that ensures that you're meeting those requirements. Sophomores, you have the opportunity to set your major for the first time. You come in, you describe you want to be electrical engineer or aerospace or mechanical or scientific computing or chemical engineering. You're able to do that, and that's something that for the first time, a sophomore will be able to do that a freshman can't normally do. Then you get to senior. You get through Dr. Morrison's coding class, you get some other classes, and you're like, finally, I get to get out of here, I get to graduate. We have all these different things that you can do, so seniors should be able to apply for graduation. There's no reason we should let freshmen be able to do that. So we want to be able to define certain tasks based on what that person is. So we break it down into two different ways. The tasks that are common to everybody, we say that we have what's going to be what we call a base class. The base class, Notre Dame student. And the tasks and characteristics that would be applied in all the other, what we're going to call derived classes, we're going to say that those base characteristics are what are inherited. And then we can call those functions in the derived classes without having to worry about rewriting them. The goal of inheritance and polymorphism is for you to be able to define several different classes of an object without having to copy and paste everything. The objective in the long run is reduction of work. So I've gone over this idea of a registration of a student. In a procedural programming language like C, we would have to define every different variant. And so this just gives you an example of why it is that we might want to write overloaded functions. A function that calls or a templated function that calls a freshman would allow a registration to do a specific thing. But if we call it register and a senior is passed to that function, then it does a completely different set of tasks. And instead of having to write 4 different versions, we would just call it a template, we'd call it register, and then be able to do those specific things. The other benefit of doing the overload is that when you are registering for classes, you don't have to worry about register freshman, register sophomore, register junior, register senior. You just say, I want to register for class, and then the program does the work for you. So that's an example of abstraction. So we have different forms of an object: freshman, sophomore, junior, senior, employee, faculty, staff, right? We can come up with different forms of this base object, this base Notre Dame employee. And it comes from the Greek for many forms or polymorph. This is why we call it polymorphism. So the base idea is that objects that are derived will inherit some fundamental objects, and then when you build upon it, you give it a different form, which is why we call it polymorphism. So when we're trying to think of when we would want to implement inheritance and polymorphism, we need to break down objects into 3 different ways. And the first way is we like to call uses a, right? A person uses a pen. A professor uses a laptop to broadcast the lecture, right? So for example, we have an array, and it has some sort of member called state. So I'm iterating through, and I have this current position here, and there's different things that we have to address. We go through an array. The array is a vector, and we're going to say that the braces are an overloaded operator, and each element in that array has an element called state. So this dynamic array uses a vector that's calling its operator to get a specific element in there. So we don't want to use polymorphism for uses a, right? There's certain things that each one of us is able to use. So this is kind of a fundamental thing. We do this a lot in procedural languages. When we did our structs, we have a point has a coordinate x and a coordinate y. But we are also using functions to be able to do specific tasks. In a class, we have methods that will do that for that object of that specific type. The next one is has a, and this is kind of what we've been studying a lot over the last few lectures about this idea of classes and structs. So we have has a, meaning a person, an object, a thing, has certain things. So for example, I got this stool, right? This stool has 4 legs. It has all these things here that are able to connect to it, right? So if I'm designing a stool, I can say what a stool has. But then I can define different types of stools. There are some stools that might be bigger and have the legs go straight down. There might be that some of them are made out of metal, some of them might be made out of wood. So we have different characteristics, but we would have, in order to define a stool, we would say some things that there are base definitions of a stool. we say that the seat must be round and it should have 4 legs. So we're going to use those as our definitions. So it has a seat that is round and it has 4 legs, but the construction of those 4 legs and the construction of those seats is up to us to define, and we can have many different forms. So a movie has a start time, a document has a page has a line has a string. And when we are building classes upon classes, we've seen this idea of aggregation, right? So we saw a line class had 2 points, and we are able to define a point class. So when we build classes upon each other to be able to find them that way, just to review, we call that 2 different ways. We can call that composition, but it's also mostly known as aggregation. Does anybody have any questions before I continue? Let me check the chat as well. So is A is where we're going to really start using inheritance. So this is our 3rd type, so we can contribute to that. So a Notre Dame faculty is a member of the Notre Dame community. A Notre Dame student is a member of the Notre Dame community. A Notre Dame freshman is a Notre Dame student. A Notre Dame senior is a Notre Dame student. When we're talking about inheritance and polymorphism, we want to say one derived class has some basic things, but we define this by saying it is a specific element. So a car is a vehicle. So I could use a class to define all kinds of different vehicles. I could do truck, I could do car, I could do bicycle, I could do tank, right? I could do aircraft carrier, I could do submarine. All these different things could be different kinds of vehicles, of which I have a derived class car that I would define as having 4 different wheels and having different size. And then I could say a derived class truck derives a vehicle, and we would define a truck in a different way. And all of these things derive from this basic idea of vehicle, which is say it's some sort of object that is propelled and can move a certain number of people. Likewise, well, we're going to get into lists in a little bit, but a sorted list is a form of a list. A student is a person. And we have all these different is a. And when we talk about inheritance and polymorphism, this is a object relationship becomes really important. So here is an inheritance hierarchy example, kind of give you an idea of when you would want to apply this computational thinking approach. So first I would say an undergraduate student is a student. Likewise, you can say a graduate student is a student. I could break down undergraduate by freshman, sophomore, junior, and senior. I could break down graduate by master's and PhD student. I could break down PhD student by pre and post qualifiers. And we would define all of these elements. And then we could say a student is a member of the Notre Dame community. So all those different categories of students would break down here into this idea of overall student. And then an undergraduate student is a member of the Notre Dame community. A PhD student who has not yet passed their PhD qualifiers is a member of the Notre Dame community. A faculty member who has not achieved tenure is a member of the Notre Dame community. Right? So we're breaking down certain things based on is a and is not. Do you guys get the general idea of this? Awesome. So inheritance in classes, when there's a lot of, like, if you're reading up on these kind of things on documents on the internet, I just want to be clear as to some synonyms, just so we're provide some clarity as to certain things you'll read. What I will typically refer to them in class is a base class and a derived class, where the base class is person, and then you have this derived class where you start adding more characteristics. This is also often known as superclass and subclass. So superclass is kind of the lowest level that you would need in order to be able to define the objects that you are using, right? And then the subclass is what I've been defining as a derived class. So these are synonymous. So the base class contains all that is common to the derived classes, and the attributes and behaviors of a base class are inherited by its derived members. So anything that's a member of the base class, and we're going to define this in a very specific way. We're going to introduce a new keyword called protected. I'll get to your question in a second. But based on this, when we get to the derived class, we're going to be able to define this information. And then the derived class, what it does is we can use, extend, or modify this data. So for example, for a derived class, let's think of sophomore versus freshman, right? So a freshman, both of these derived from a Notre Dame student. The student has an ID. We could say some sort of inserted value for a number of credits. We could say that you have certain rights and privileges. And then when we create a new version of sophomore, sophomores are able to do different things. They're able to declare a major. They're able to have more privileges than a freshman does. There are certain things that freshmen can do that sophomores can't. We want to be able to build off of this base class and then differentiate between them using these different types of classes. So, what's your question?
So, is the terminology for base class or super class, is that relative? So, like, if, for your example of person, student, freshman, could you call like student a super class when you're talking about freshmen?
Yeah. But to be clear, on a homework assignment or an exam, when I refer to them, I'll refer to them as base class and derived class, just to keep it consistent for the course. Now, are there any other questions? Let me check the chat as well, see if we have a question there. All right, so now we can go into this in a lot more detail. So I'm going to have a base class called Irish, and we're going to have a derived student class. So a student is an Irish, right? So we assume that the derived class publicly inherits from class B. So we call it class D and class B, and the terminology for the base class will be in light blue, and green will be the derived class. So class D student, class B is Irish, right? So here, every object of type D is a type B, but not vice versa, right? Every square is a rhombus, but not every rhombus is a square, right? So likewise, every Notre Dame student is an Irish, but not every Irish is a Notre Dame student. So we can think of the derived class as a more specialized version of this. So the further and more detail we go into what a student is, or the further and more detail we go into a staff member is, or to what a faculty is, we can define these specific things. And by using C++ object-oriented programming, we can derive from a base class in a way that allows us to use the functions and methods that we want to use, but then change things to be able to get a different version of it. So anywhere an object of type B can be used, an object of type D can be used, but not vice versa. So think of it this way. I've created an object Irish. So Irish has some very basic things. We have an ID number. We have some sort of basic things, keeps track of the user's information. So if I call an Irish, that means I can just understand that this person should be on campus or does something here. Whereas I can't say, all right, an Irish can register for a class. So in order to register for a course, you would have to be an admitted member of the student body. So one thing you can do, other things you can't. So I have the example there. I would say a faculty cannot go into a student dorm. You don't want me there, I don't want to be there. It's good for everybody, right? So there's certain privileges that certain classes and certain inherited and derived objects can do. So we're still good here on chat questions. Okay, so what I'm going to do is throughout the rest of the lecture, I'm going to show you examples, and I'm going to show you some rules that I've developed that will help you because we're eventually going to do a lab on Friday where we're going to do some, get your hands dirty with doing inheritance and polymorphism. And then homework 8 that will be assigned next week will be an inheritance and polymorphism assignment. So the first thing you should do is you should create a destructor in the base class. And before it, you should use a keyword called virtual. So that's the first rule. And we're going to define a virtual function as a member function which is declared within a base class and is going to be overridden or redefined in a derived class. So if I say it's virtual, then here's what's going to happen. Let's say I have a virtual method, let's say student, right? And in that I have a method called register. So I would call it virtual. And then what will happen is if I have a derived class freshman, I'm going to use polymorphism to write a new version of that method, register, that is specific to freshmen. Then I would do the same thing as sophomores. I would use a very specific register that's specific to sophomores. And all of those would have those unique polymorphic versions of the method. And the student would say virtual register, and that would be the base version of it. If I called register on student, though, it would operate as normal. Does that make sense? So virtual allows you to change things in a derived class, but still can be used on its own. And one of the reasons this is helpful is that you, the programmer, can dictate which methods should be polymorphic and which ones should not be. So if it's not virtual, you are dictating that any object that derives from this class must use this method as defined. So you maintain a form of control. So I have as kind of a base, two sub rules as part of this. So the first thing is if you are, as I talked about this rule of 3, right? So the rule of 3 should be applied if you have some sort of private member that allocates memory. It's a pointer or an array or something like that. If you create a destructor for an object and you don't have any pointer memory, then you don't need a copy constructor or an assignment operator. But you just still need to write the destructor. And I know in previous lecture I described that if you have a destructor, you should do these other two, but this is the exception to that rule. The other crucial thing is if you're splitting it into .h and .cpp, you only want to use the virtual keyword in the .h file only. You don't want to write virtual when you're writing the method definition in the .cpp file. Okay, so does anybody have any questions about rule 1? All right, rule 2. Any private members or methods in the base class that you wish for the derived class to have access to should be put under a protected keyword. So if you have private members and methods in a base class, and you want those to be private members of a derived class, then instead of saying private, you say protected. Does that make sense? So now what we're able to do is we're still able to maintain that data hiding that object-oriented programming affords us, but at the same time, we are then able to say, all right, a student has a private member net IDs. I want every freshman, sophomore, junior, and senior to be able to have that as a base version. When it derives it, it should inherit that. So in order to do that, I will change that private keyword to protect it. So that's the second rule. All right, so first what I would like to do is I'd like to show you a base class, irish.h. And so this is the .h file so let me zoom in here. I'm going to show you how we applied these two rules to allow this Irish class to be inherited from and allows us to be able to do polymorphic operations. So as with everything else, I've done the pound if not defined, pound define, and then end if at the end. Here I have string and IO stream. First rule, before I even go to protected, the first rule is in my destructor, I have the virtual keyword in front of it. So you see that? Which means if I go to the .cpp file, let me ask you all a question. Should I have virtual in front of that method definition in the .cpp file? Yeah, a lot of head shaking, no, very good. And in fact, I will show you this and we will see the destructor does not have the virtual keyword. So very good, you're all absolutely right. All right, so now the second rule. In the second rule, you'll notice that I no longer have a private keyword here. I call this protected. So in this Irish class, every single a class that derives from Irish will have a last name and a first name, an NDID, and a string for a home address. So these are fundamental aspects for everything. Okay, does everybody understand that? So I would be able to access those in every other derived member. And so what I have here for Irish is I have a constructor that sets standard string, last, first, and unsigned int, NDID, or N. And then for Irish.cpp, you'll see that I have last name, first name, NDID, and then I call the default constructor for the name there. Now, does anybody remember, just for a brief review, does anybody remember why it is that we enforce putting in the members of the class in the constructor in the same order that we define them in the class.h file? Does anybody remember why we do that? There's a really good benefit, and I'll give you a hint. It has to do with a lot of memory allocation pointers and stuff. Let me bring this up, see if anybody remembers on the chat. Who wants to take an educated guess? All right, so what is this pointer? Do you remember what the this pointer is in C++? What is that pointing to? Yes. So it's the very base address of the class object, right? Very good, absolutely right. So if I have a pointer to the class object, that's the base address. It's like a void pointer. So what do you think is going to be the first few things that we find at that memory location in the class object? Yes. Yeah, we're going to find the different variables. So in irish.h, we would find a string for last name, a string for first name, a string for NDID, and a string for home address. So based on that, why do you think it's in our best interest to put them in the member initialization list in that order? Yes. Very good. The crucial thing is it can iterate down through efficiently. Because it's moving this specific way, I would start, because last name and this are pointing to the exact same location. And then first name is just we move down, and then NDID we move down, and then home address we move down. So this is the most efficient way to be able to declare the class object. And to give you some perspective about why this is beneficial, I have a data structures, what I call pre-internship project team that's working with GE Healthcare, and they're defining a class that has 150 private members. And so they want to be able to define all that information. They're reading in from a neonatal monitor. They're trying to read in all this information as fast as possible to be able to make a decision. So going in and going through one by one in that order makes it beneficial. So that's why you'll see this. If just posted homework 7 this morning, you'll see that I say in there you want to go in this order in the member initialization list, and that's why. And you'll see here when I print this out, I'm going to print the base address of the class object. Okay, you'll see that I have the virtual destructor. I've changed the keyword to protected. And now, and here's what I've shown you with everything in terms of the a base class Irish. And if I run make Irish test, what you'll see is I've created two objects, right? And so I've created student Jones here, and we have 101 Main Street. We have 202 Notre Dame Street, and put in some, here's my name, put in a fake ID, put in a fake address. But notice how it says base address of Irish object, and we have two different addresses here, and it says destroying base class Irish twice. And the reason why is because in the constructor, I print out standard cout as well as this. And then when I call the destructor, you're just going to see that I'm destroying base class Irish. So the reason why I'm doing that is I want to show you something when we actually derive this later on. And so this is how we actually develop a derived class. So rule 3, in the derived class declaration, the format is, and this is important, you're going to use all these keywords, class, and then the name of the derived class, and then a colon, and then public, and then the name of the base class. So it's class, derived, colon, public, and base. And so here's an example. So I want to have a student class that inherits from a base class Irish. The way I would do this, I would do class, student, colon, public, Irish. All right, so here I have an example of a templated derived class. If you were going to do a derived class from a base class that is templated, then you need to have the templates there with the same generic types. And then it would be class, derived class name, colon, base class name. And it's important that the base class be templated in that definition as well. Does everybody see that? So that's rule 4. Yes, question. Okay, so remember earlier, I think it was 2 lectures ago, actually no, it was last lecture, where a template is a generic object that we can use to overwrite variables in a class. So if I want to have a class that can have different variable types, so I can say int, float, double, standard string, whatever I define it, we can use these what are known as generic variables to be able to overwrite. So here, what I have is, this is actually some code I've written for what's known as a quadratic probe data structure. And the way that a hash table works, it requires a key and a value. And I can have that key be any type that I want, and I can have that value be any type that I want. So therefore, I could say quadratic probe integer string. I could use some sort of integer to find a string as fast as possible. I could have it be a character and a double. I could have them be whatever I choose them to be. So we're overriding it, and it does it in real time. Did I address your question? Awesome. Are there any other questions? Let me check the chat as well. Okay, rule number 5, for private members or methods in the derived class, you only need to add members and methods that, you only need to add members that are unique to the derived class. So for example, for student, no need to include last name, first name, net ID, or home address, because we have all those. We are inheriting them. So rule 5, if we do not need to rewrite all of that in the new class. Okay. Rule 6, when you are designing a constructor for a derived class, the very first member of the initialization list should be the constructor for the base class. So here's what I mean by that. So here I'm creating a constructor for a student, right? And I have all of these inputs. And so the first thing is you'll see that Irish, and I'm calling the constructor for an Irish. So the way that an inherited class is actually working is that it's pointing at the same place, but what's going to happen is the first objects that are allocated on the data heap are the objects from the derived class. And so that's why we need to put the protected keyword, so we can say, all right, these are the objects that I want to put on the data heap in order for me to be able to allocate this class. Then you'll see that I have two other members of this class. I call it student class. We were able to define their class rank and their dorm. Right? So for the dorm, we're just going to say that we haven't assigned it yet, because in reality, you first get admitted, and then you're defined as a freshman, and then eventually at some other point you get assigned your dorm. And then here at the bottom, we won't quite, we're not going to go into this quite yet, but this is another example doing the same thing where I have a constructor, and with a templated type, I call the constructor there. The derived, in rule number 7, the derived class must have a destructor even if the derived class does not have a pointer as a member. So the base class must have a virtual destructor, and the derived class must have a destructor as well. It's very often that these destructors, you won't write any code inside of the braces, and that's fine. But we're going to see what's going to happen when I call and define and destroy these objects. The other crucial part is don't use the virtual keyword in a derived class unless you plan on having that derived class serve as the super class for something else, or serve as the base class for something else. Does that make sense? Give everybody a moment to take some notes. Yes?
Why is that? Is that like more efficient to not use virtual, or will it pop up an error?
It will pop up as an error. And the reason why is it should have some sort of way in which you can derive that. If you're trying to set it up to derive, but it's not actually going to derive anything, you're just reducing code security. Any other questions? All right, let me check the chat as well. All right, so the first thing I'd like to do is I want to show you student.h and how I go through this. So ignore that line about enum for right now. I'll describe that in a moment. But here is that first rule I described where I have student, class, student, colon, public, Irish. So it's deriving from that Irish class. And you see that I also have pound include Irish to make sure it's there. Then I have two private members. So what I have done is I have created what is known as an enumerated type. An enumerated type are keywords that I can use to define values. In this case, an enumerated type is kind of like a struct, except what I'm going to do is I'm going to say, all right, I'm going to use these keywords, but really what they're going to mean is 0, 1, 2, and 3. So everywhere you see class, if I say class, if I say it's equal to freshman, what we're actually saying when we compile it down and break it down to the architectural level, we're actually saying that this is actually equal to 0. So an enumerated type allows us to make keywords in such a way that allows us to define a specific ordering. So let me give you an example of when an enumerated type, a very simple example. If I wanted to create an enumerated type month, it would make a lot of sense for me to go January, February, March, April, May, June, July, and so on, right? And that would define it as 0 through 11. But when somebody's coming by and looking at that code, and I say this month variable is equal to February, that makes a lot more sense than month is equal to 1. Because since it's an offset of 0 through 11 instead of 1 through 12, what ends up happening is somebody might read your code and go, oh, 1, first month is January. And they would actually not interpret your code correctly. So you can use this enumerated type to be able to define your code in a way that makes sense to the user. So it's kind of like pound define, except we put them all in a specific type. Okay, does that make sense? Yes. Oh, it's just going to be there. It's going to be an integer waiting for us to define it. Which is what takes me to the smoothly to the constructor. So here I have the constructor, and in the .h file, I have them in the same order: last in, first in, NDIDN, and then I say class in. So what I'm going to do is I'm going to now show you in the student.cpp file how we're going to set up this constructor. In the constructor, what we're going to see is I have all those inputs, and then in the member initialization list, we're going to follow that first rule that I'm going to call the base classes constructor. So in this case, Irish, and I put them in those same order. So now it's putting in the same order on the data heap, and then I create the 2 objects of the derived class. So these are what are unique to this particular member. Did that address your question? Awesome. Are there any other questions? And we'll do the same thing, check the chat again. And you're going to see that here I'm going to say base address of student object, and I'm going to print out the address of this. And then again, you're going to see that I have the destructor, and all I'm doing is just printing out destroying derived class student. And now I have this class, this method, and I call it get class. So to go back into this idea of enumerated type, what's going on here is that it's a switch statement. And if you remember from C, I hit on this idea that switch statements have to be done with integers or some sort of unsigned int because it has to calculate an exact location, right? So now I'm using freshman here. Now I'm using class here. Enumerated types are ultimately unsigned integers. So here it's just saying switch class case 0, and that's what we're replacing with freshman. And here I'm returning the string freshman. So I'm converting it from a 0 to 1 to something that can be read by the user. Does that make sense? And that'd be the same thing for sophomore, junior, and senior. All right, so first let me go back to the slide we just got off of, and I want to describe the 8th rule. So the 8th rule, you have to rewrite a completely new friend operator in order to be able to print elements out. And you'll notice here that in the friend operator, I'm able to just call dot last name, and I'm able to access the private members of the that are inherited as part of the base object. So you see that? So that's an important thing. So I'm going to make a crucial differentiation on the next slide. That in a friend operator, I am able to access all the members, both inherited and members of the private class. And so in this operator here, you see you may see that student.last name, that's inherited. Student.first name, that's inherited. We see get class, that's not inherited. Student.dorm is a member of the derived class only. So we have to rewrite the entire version of this in order for it to work. Right, where's this this crucial thing? Okay, here we go. Sorry, I thought this slide was much earlier. So let me show you this function here. Print information. In print information, this is a method of a derived class. And what's going on here is that if I am trying to access the members of the class, right? So a student is a derived class. Here's our last rule for the day. If you are accessing a member of the base class, for example, last name, right? Everybody see that? And it's not a friend operator, you must use the this keyword in order to access it. And all that stuff that I skipped over, that's gonna be my justification why in a moment. So here you see this last name, this first name, those are inherited members. So we must use the this keyword. Same thing with NDID and same thing with this home address. And so because this is a derived class student, I have another code there with a derived class called faculty. So here you would get class rank and you can get dorm, and you see that I am not using the this operator because those are members of the derived class only. Does that make sense? So for the same thing, I have faculty.cpp. And if I go down here, we see that, so that's the friend operator. Friend operator, you do not need to use this, but in faculty print information, the base objects from Irish, this arrow last name, this arrow first name, this arrow NDID, this arrow home address. In this case, I could say get track, which is a method that returns whether or not they're in tenure track or teaching track faculty. And then a department, which is the department in which the faculty member is employed. So you can see the difference there between this and not this. So let me scroll back here. So I just showed you all that. And what I'm going to do is I'm going to run make inherit. And there's several things I'd like to show you. So inherit, you'll see that run clear, make clean. So first, in the make file, you'll see that I'm making the inherit, that contains the main function. Then you'll see I have Irish, student, and faculty. So I'm compiling the base class and then the derived classes, and then I'm taking all the object files and putting them together into the executable. The next thing I have here is where I'm printing out the this object, right? That's the address. See here, base address of Irish and base address of student object. Those are the same address. So both of the this pointers are pointing to the same location. The same thing, I have a faculty object. Those two addresses are the same. These two addresses are the same, and these two addresses are the same. So I've created 4 different objects, but in reality, it's 4 different objects that are built off of 4 base objects. So then I use the operator. Here I have new guy Jones, print out some addresses here. Julia Smith, Patrick Flynn, Matthew Morrison, and we see that it prints out unique information. And then what it's doing at the end is it's saying destroying derived class faculty, then base class Irish. Destroying derived class student, then it's destroying base class errors. So it has two registers pointing, and it's just deleting all of those. Does anybody have any questions about anything we've covered before I dismiss? All right, on that note, it is 10 o'clock and you are free to go. I will see you all on Friday.